Okay, so here are a couple problems from finding limits algebraically. Um, First of all, I feel like number 3 can be tricky sometimes. And again, I just kind of I picked a bunch that I thought would be helpful. If there's one that you need that's not on here, absolutely just pop up to my desk and ask for help. I just tried to pick a good selection of these. So here, if you can plug in your number and not get a negative under a radical or a 0 in a denominator, then you want to plug it in. So I'm going to plug this 1 in for x. So I'm going to do this. 10 times 1 minus 1. So that's going to give me the square root. 10 times 1 is 10, minus 1 is 9. And that one is 3. So there, the limit and the actual output of the function are exactly the same. So that one's a nice one. Number 5 is where you're going to have to start doing some work. Because if we take this 2 and we plug it in here, now we get 2 minus 2 is 0 in our denominator. And that's not, we're not going to be able to find the limit that way. So I'm going to keep my limit notation going. And I'm going to try to factor my way out of this. So in my numerator, I need two numbers that multiply to negative 2 and add to negative 1. So that's going to be x minus 2 and x plus 1. That allows me to cancel that x minus 2 in the denominator. So I'm basically factoring and canceling myself into being able to take the limit. So what we know is that there was actually a hole there at 2. And so the limit, once we cancel that hole away, we can plug in that 2 for the x. I didn't mean for both those limits to be 3 back to back, but that works awfully nice. Okay, number 6. So number 6, this is where a couple challenge problems get thrown in. The algebra with these is very reachable, and it's something that you've seen before. But this problem is definitely, it's a little different because we're not just going to rationalize, we're going to rationalize the numerator. So for this one, if I plug in the 4 for the x, the bottom is a problem. So I can't do that. So instead, I'm going to rationalize the numerator. I know to do that, basically, or the reason I know to try that is that I see that square root in the top. So I'm hoping that if I multiply by the conjugate, it will work out for me. So I'm multiplying by 1. It's a fancy one, of course. And so it doesn't change the value of my equation, but it is going to change how I can write it. You'll notice I'm going to keep going with my limit notation. In the numerator, I'm going to multiply this out. So I'm going to do square root of x times square root of x is just an x. I know my middle terms are going to cancel, but I'm going to go ahead and write them out for you. 2 times radical x is positive 2 radical x. And negative 2 radical x. And then I have negative 2 times 2 is negative 4. So there my middle terms are going to cancel. So my numerator is just going to be x minus 4. That's awfully nice. Because of that, I'm going to leave my denominator the way it was. So my denominator, I'm going to leave in factored form. X minus 4 times square root of x plus 2. Just going to rewrite and clean this up. I have x minus 4 on top. I have x minus 4 times square root of x plus 2 on the bottom. And now I can cancel my x minus 4s. And that gets rid of that piece of the equation that was causing the problem for us for finding the limit as we approach 4. So I have a 1 on top and square root of x plus 2 in the denominator. And now I can take that for, now it's safe to plug in because I'm not going to get a 0 in my denominator. And you just awesome. So those were just some selected problems from that finding limits algebraically practice 3, 5, and 6. I'm going to do another video with a couple more of the more challenging algebra problems for you as well, so you will have those to enjoy.